after the discussing those questions, we will discuss something about the office hour. So just 1 minute. Hope my screen is visible. Is it right?
Yes, sir.
Yeah. So as Subhajit is saying, at the end we will discuss what is office hour in chat. So the question is asked by Anand, which is the question from week one practice assignment, and the second question is asked from Ranjit, which is also a week one of the activity question. So let me open that exact question. So Anand is here. I hope, is it? Yeah, so Shreya is asking where do we need to type our doubt for it to be addressed. So yeah, those we will discuss after discussing this question. Yeah, that's the thing of office hour. Those we will discuss. Let's finish this two question, then we will discuss about the office hour. You will post the queries how you will attend uh, and other things also. So question is of this question practice assignment. Third question. So this is the practice assignment. Third question. A triangular method. He asked all four options. So the first option is a triangular matrix of order 3, which is a square matrix, you can say in the other word, as non-zero determinant if and only if all the diagonal entries are non-zero. So the first option is asking about the is this option is true or false? Triangular matrix which have a non-zero diagonal entries. So we can assume let's triangular matrix, let's say upper triangular or lower triangular. So that means A, B, C, and all diagonal entries are non-zero. So let's say this is E, D, E, so 0, 0, 0, and this is a F where all entries. If we go one side with the actually in this question, if and only if condition. So first we have to prove a triangular matrix has non-zero determinant. So we have to prove the diagonal entries are non-zero, and reversely we have to also prove if the diagonal entries are non-zero, then triangular matrix has non-zero determinant. That's the mean of if and only if condition. Whatever I am saying, is it audible, right, to everyone?
Yes, it is audible.
Yes, audible.
Okay, fine. Okay. So I am assuming first this the first way that a triangular matrix has a non-zero determinant. So let's say this is an upper triangular matrix. So determinant of any upper any triangular matrix is the multiple this multiplication of the diagonal entries. Let's say this is A. So determinant of A is A, D, and F. And actually the reason is you can take this entry as you know that the definition to get the determinants is A times determinant of leaving these entries, which is DE 0F. And if you take this determinant is actually this one DF. So final thing is A times DF. So because of this, the determinant is just diagonal entries, multiplication of the diagonal entries. So as the first we are taking this one non-zero determinant, that means this is non-zero. So that means any A, B, and D are non-zero. Then if any one will be zero, then it will become zero. It says that diagonal entries are non-zero. And if we go reversely, uh, uh, which is here, if any one will be zero, then the determinant will be zero. But we want the reversely says that the diagonal entries are non-zero. That means the determinant will be non-zero. So this option, that's why this option is true. The second option is if A and B are of order again 3, square matrix of order 3, then determinant of A plus B equal to determinant of A plus determinant of B. So actually this is not true. You can take any let's say any square matrix of order 3, which is you can take like diagonal itself, or maybe any. Actually this is not true. You can take like this, and, yeah, okay, of zero determinant, and this is, let's say, zero matrix or not non-zero. Let's say this is again 2 here, 3, 0, 0, 5 here. This is a matrix, and another matrix is, let's say, let's take lower triangular matrix, which is 2, 0, 0, 5, 0, 3, 1, 2. So determinant of this matrix is actually the multiplication of diagonal entries, which is 10 here for this matrix, and for this matrix is again this is a lower triangular matrix, so determinant will be 10, 20. And if we add these two matrices, we will get matrix will be 2, 1, 1. Here 2, not 2. Here will be 3, and this is 0. This is 7, and this is 3, and this is 3, 1, and this is 7 again. So determinant of this after adding these matrix We will get this matrix, and determinant of this matrix will be, if you check that, it will be, let's, I am asking from you, just find the determinant of this matrix and let me know what will be. And if we add these two, it will be 30. And please calculate that this determinant of this matrix and let me know what is the determinant for this matrix. Please everyone do this.
$147, sir.
Okay, 147. Let's wait another response. If that will be matched, then our answer will be like, determinant will be 147. Is it everyone is getting 147? So I am leaving to you. You can check actually.
It's coming 42. It's coming 42.
Okay. So I am writing two answer here. So actually both are some different from these two. So actually that's the main determinant. This is not true for in general. Maybe in a specific case can be, but in general this is not true. So let's move on the next option. The third option is if A is again a 3x3 matrix and B is a matrix obtained from A by multiplying each column of A by its column number. So then asking for determinant of that matrix which we obtained is equal to 6 times determinant of A. So let's evaluate the, let's say a matrix is a general matrix, let's say this is A, B, C, D, E, F, G. This is the matrix here, and matrix B is obtained from A multiplying each column of A by its column number. So if you go any with, like if you are assuming this is column 1, this is column 2, this is column 3, or that's the usual way, or if you are assuming any, this is 1, this is 2, this is 3, so it will not depend on the order. So let's assume this is column 1, this is 2, this is 3. So the B is obtained after multiplying the each column with the column number. So it will be the same, because when we multiply this column with 1, it will be the same. The next second column will be 2B, 2E and 2H, and third column will be 3 times C, 3 times F, and 3 times I. And you know that in week 1 and also you gone through week 2, so you can make it out 2 and this 3 also. So this is actually equal to 2, 3, and a determinant of this B matrix is, you can make it 2 out and 3 out from each column, and determinant of the usual matrix which is A is the previous one, which will become a previous one, which is determinant of, which is 6 times data of A. So this option is also true. Now the third, this fourth option is if the sum of the first and third row vector of 3x3 matrix A, of a 3x3 matrix A is equal to the second row vector of A, then determinant of A equal to 0. So you know that if we, if this is the matrix, and if we multiplying the second row, or maybe I'm in general case I'm saying, okay, no, so in chat I'm looking, it's my internet issue or your, am I audible? audible clearly, right?
So we can hear you, but someone's voice is robotic.
So they told me like credits you have the BSc level credits are like 120 to 140 and the BTech level credits
Let
are
me
of
mute you
about
all.
180 plus. So they said if you had the
So I muted to all. So, and yeah, so I was discussing the fourth option, and which is so in general, as you have seen, if you are this taking this row and multiplying, let's say this is I'm making the 8 plus b time, let's say b not, this is we multiplied second row with alpha, so this is alpha d and added to the first row, and b plus alpha time e and c plus alpha time f, and as it is we obtain a matrix which is after multiplying the second row with the alpha and adding in the first row. So determinant, whatever we obtain this matrix, so determinant of this matrix, which is let's say this is matrix C, so it will be equal to the determinant of A. It will not affect the determinant. So I hope you can get this how it's happening. So uh, anyone can unmute and tell it what is this option is true or not because of this reason. So this option is just from the video lecture you can tell. So I am leaving this option to you. So let's move on the second question.
I think this is true, sir.
Yeah, actually this will be true because of you will get the two rows as equal because the determinant will not affect. So two rows in a matrix equal, when this will happen, then determinant will become 0. So you can because of this reason, yeah, this option will be true. Yeah. So let's move on the next question, which is asked by Ranjit, and this is asking let A be a square matrix. Let A be a square matrix such that A square is equal to if A. If we are giving like this, so in this question he is asking for like how to deal with such questions. The question, if we are given a statement like this, what is the easier way to determine such matrices or entries of the matrix or element entries, we can say in proper word, entries of the matrix say. So let's do this. So assume a square matrix we can take of order 2 itself. So the question is, what will be, is there, suppose a matrix, square matrix of order 2, and this is happening. So leaving to be, let's say this will true for 0 matrix and identity matrix. Leaving to how we will get there are such matrices or not. So the best way is we can take a general matrix, like we can entries we can take as a variable kind. Like let's say this is first entries is A, B, C, D. So and saying this should happen. So let's multiply A square will be multiplying A, B, C, D with this, and you will get here it will be A square and this will be plus BC, and the second one will be AB plus BD, and this will be AC plus CD will be BC plus D square. If I made somewhere mistake, please stop in calculation. Now this says that A square is equal to A. So which is our A, B, C, D. We are trying to get the entries. So now if you compare these two matrices, it will be A square plus BC is equal to A, which you can write A square minus A plus BC is equal to 0. The second one is AB plus BD is equal to B, and this you can write it if you take B or maybe AB plus BD minus B equal to 0, which is if you take B common, as it will become A plus D minus 1. From this and this, if you compare, it will be AC plus CD, which is equal to C. Again, this will be this side, if you take this side, it will be C time A plus D minus 1 equal to 0, here equal to 0. And this says BC plus D square is equal to D, which you can send again this side, and this is equal to 0. Now we have these four equation, and from these four equation, we have to find the entries. We have to guess the entries, or you can say we have to find the entries which satisfy these conditions. Then it will be happen, right? A square is equal to A. This will happen. So how we will guess this? How we will put the entries like here? So let's say these are two numbers here, variable. So this says that if you take B is equal to 0, then let's say A plus D minus 1 not equal to 0. So here this says B and C equal to 0. From here B is equal to 0, and from here C equal to 0. So that means you are getting something like, if we apply these and this condition, then entries will be here, B, C will be 0. We can put here 0, 0. Now the condition here, as obtained after applying the condition A plus D minus 1 not equal to 0, B is, or you can take both 0. Here is the 0, or you can both 0 as A plus D minus 1 equal to. Here this condition says that either B equal to 0 or A plus D minus 1 is equal to 0, or both can 0 also. Whatever you will take. So I am assuming, let's say this is happening, that B equal to 0, C equal to 0, and A plus D minus 1 is equal to also 0. So as in this equation, BC is equal to, as we obtained B and C 0, this will become BC is equal to 0, and this says A square minus A is equal to 0, which says A minus 1 is equal to 0, which says A is equal to 0 or 1. Similarly here, this says again B, C equal to 0, B, this will become 0, and this says D square minus D equal to 0. Again, this says D equal to 0 or 1, as you take D minus 1. That's common. So now you can guess the entries, like you can vary here the number, like here you can substitute 1 and D 0, this, or 1 here 0, 0, 0, 1, this will happen. 0 matrix is also here, and identity are there. Or if you check, the condition will also satisfy like this also. These are the matrices. After looking these conditions, you can guess that what entries, like we are trying to get here only the integer values. You can also get rational or irrational number. So using this, like whatever I did here process, using these process, you will make some equations or some relation between A, B in the entries A, B, C, and D, and try to get a matrix. Like as I here got, this can be, this can be. If you check that, this will be the same. This will satisfy A square is equal to A. This will also satisfy. We can check here. So this will become 1, this will become 1, this is 0, this is 0. So this says that this will also satisfy, this will also. So what I mean to say that you will whatever the equation here says, and taking a general matrix and find a relation between the entries and applying the condition on entries, try to find following this condition, and you can put the entries according to that, and which says that yeah, there are some real matrix which satisfy this. There are complex matrices also which will satisfy this, but for the maths 2 or maths 1 we are studying only on the real number. So hope you get that what I mean to say, how to get these, how to resolve these problems. Is it? No? Am I audible?
Yes, sir.
Yes, sir.
So whatever I told, is it clear, right? What I mean to say for solving such type of question.
Yes, sir.
Yes, sir.
Yes, sir.
And
Yes, sir.
And the previous one just I discussed. So today for office hour, for today only, we discussed these two. So I am saying to Subhasis, we will discuss something about the sorry, Subhajit, we will discuss about some office hour. So hi Subhajit.
Yeah, so am I audible?
Yeah, you are audible.
Okay, great. Okay. First of all these live sessions should be little more interactive, right? I mean,
Subhajit, just I want to, your voice is somewhat like, can you
okay.
speak some away from away?
Miko is coming.
Some echo is coming.
Okay, 1 minute. Is it little better now?
Yeah, it's now.
Okay. So yeah, so this live session should be little bit more interactive. And then actually, I mean, whenever we are asking some question, then we should, we should get some reply from your side also, right? And okay, first of all, how many of you know about these office hours?
Sir, I don't know.
Okay,
Yes, sir.
anyone has any
We
idea?
know.
What?
Don't,
We
I
don't know
also
the
don't
concept,
know.
sir. We don't know the concept.
Okay. And how many live sessions are in a week? Do you know that?
No,
2
sir.
to 3.
It's about, sir, eight.
Two.
It's about
Three.
8 sessions.
No, for one subject. I mean, for maths.
Three, sir.
Okay, so
Three,
three.
sir.
Three.
So three to
there
4,
are,
I think.
No, there are 2 live sessions.
Yes, sir.
2 general live sessions. That is, one is on
Friday
Friday
session
morning.
and another is solve with us.
One is Friday morning, another is solve with us session, which is Tuesday evening, right? So just before the Wednesday deadline for the graded. So those 2 are the live session. Now there are many working professionals are there, and there are many time constraints for many of you. So we are arranging 2 office hour session, which is at the evening time, and I mean from 8 to 9. One is on Saturday, another is on Monday. So these 2 are office hour session. Now, Shubham, can you stop sharing? I will share something.
Yeah, sure.
Yeah. Okay. So yeah, my screen is visible, right?
Yes, sir.
Yes, sir. It's visible.
Okay. So if you go to the course in introduction session, in a section of your portal, then there is something called office hours, right? First of all, in general instruction and important links, all the links are there. So those who have not register for discourse. I mean, those who have not seen what discourse is, I request you to go to discourse. Many of you are posting your queries there, some of you are answering there, so that is a good place to clear many of your doubts. And then this is office hours. If you open it, there is a form, so post your queries using this form, right? So if you click on this form, you will see a Google form. You have to write your name, the week from which you are asking your question. You can ask your question from the back week also. I mean, suppose we are in week 3, but you have some doubt in week 1, still you can ask your doubt here. Okay, now post your specific question or doubt. So here what we mean, just don't type week 1 AQ 1.3 question 3. We are not asking for that. Okay, you specify what your doubt is. I mean, suppose you are trying some activity question or practice assignment or even previous week graded assignment. You tried that question, you are trying that question and you are stuck at some point. Now you are not clear which concept you are going to use. Then you can write that thing here. Okay, or suppose you don't know what how row echelon form behaves with Gauss elimination. Suppose this concept is not clear to you, then you can write it. Okay, I mean, you can write directly about some concept which is not clear to you. So this place is where you have to write all these things. Now explain why you are facing this doubt or query. So you mention which week that is and what you have tried, and at the end, suppose you are working some problem, then you can attach your rough work here. So this is not compulsory, but it will be better if you attach your rough work for some specific problem where you have stuck with. Then we will also love to see how your approach is, right? So that will give us a great idea that how our student are doing. Okay, so if you fill this form, then your query will come to us, and you can check once you fill the form, you can check at this place. So your name will come here automatically along with your query. So you just have to put everything in the Google form, and you can see whatever you have written in the Google form will come here, right? And then this place, at the beginning, this place will be empty because we will post a link in this place. So suppose your query is already addressed in discourse. Suppose someone has already asked this and there was a discussion in discourse. So we will post the discourse post link here. So you can, like we have already posted some 2-3 discourse link here. So you can go to the discourse link and you can read the discussion going on there regarding your problem. So that is one thing. Next, suppose that query is not discussed in discourse and not discussed anywhere. So then we will post the live session link like we have done in this week. So corresponding to your query, you will see the live session link here, and we will say attend the date and the hour of the live session where you have to come. So then, I mean, not only who have just asked the query, any of you can come here to hear what the discussion is going on in this live session. So that is basically the concept of office hour. Okay, so this is more specific to your problem, which is not addressed in the open session previously, or even after the week is over, the graded assignment submission is done. Still, if you have some doubt, you can clarify it here. Am I clear? I mean,
Yes, sir.
do you have,
Yes, sir.
yeah.
Yes, sir.
Yes,
Yes,
it's
sir,
great.
yes, sir, you
Yes,
are
sir.
Yes, sir.
So
It will help.
now, yeah. So now you can just. So first of all, I will ask everyone, whenever you have some doubt, go to discourse first and search about the keywords. Right. Suppose you have doubt in Gauss elimination. So we are in secondary. That's why I am just referring Gauss elimination. So go to discourse link here, and you can. So my discourse link will be little bit different because I am from the instructor perspective. So you will go there, you will search about the keyword which you are searching. My network is okay. So you will search about the keywords which you want to know. Then you will see so many posts will be there, right? Regarding Gauss elimination, suppose there are 10 posts. Then you can specify what your doubt is. Then you will filter those queries, and you will, if you can see what your doubt is, it matches with some question, then you can read it there. Even after that, if you have some doubt, you can post in the same thread, so that we can, that will be easier for us to clarify the doubt. I mean, still after the discussion, there may be some doubt which you have. Okay, so we will clarify that thing. And then if you just want to come to the live session to do it more, I mean, more systematically or more interactively, then you post that in office hour. I think you will like to do it interactively. So you post it in office hour, and then again we will arrange this kind of session. So if we don't have any such queries in our list, in this list, suppose in 1 week there are no such question. I mean, all the questions are either addressing discourse, or some questions are just activity 1.2, question number 2, like this. So we will not address all this question here, because that question is easier to discuss in the discourse. So if we don't have any question, then there will not be any office hour session, but we will happy to conduct office hour session. Okay. So that is the point of all this.
I want to say something.
Sir, I have
Yeah,
a
yeah,
small
go
doubt.
ahead.
So can I?
Yeah, you can.
Okay, go ahead.
Okay, so my doubt is for the augmented your matrix, when you perform a reduced row echelon form,
Okay.
so the objective that generally for the B part, we should keep the B part non-zero, try to keep it non-zero, or how should we approach to find the x1, x2, x3's values?
So there are two type of system of linear equation, right? One is homogeneous, one is non-homogeneous, right? Have you seen that?
Yes.
So homogeneous means ax equal to 0. That means the B part is 0. Okay. And non-homogeneous means the B is non-zero. I mean, at least some one BI should be there that is non-zero.
Yes, yes.
Okay. So there are two type of system. Now, when we are working with non-homogeneous, obviously you have to keep track of B.
Okay.
That's why the concept of augmented matrix came in the picture. Otherwise, if we are only dealing with homogeneous, then there is no point of tracking what is going over the B vector, right? Because whatever operation you will do, it will always be 0, right?
Okay.
So you can only work with coefficient matrix.
Okay. Because what happens, sir? For generally, if you deal with like coefficient matrix, you in the case of your reduced echelon form. So generally, we try to keep 1, 1, 1 in the diagonal phase, and rest is 0. We try to keep this in this format. So, but when this is for augmented matrix, we don't try to do this, right? For the last column, that B part column.
No. So basically, so there is one mistake you are doing. Rakesh, is it?
Yes, yes, yes.
Okay. So there is one mistake you are doing. That is, when you are tracking the row echelon form, you should focus on the rows first. Okay. Column will change automatically. Okay. That's why we are doing row operation. Okay. And that's why we call it row echelon form. So keep track of row first. Column will change automatically.
Okay.
Don't focus on the column at the beginning.
Okay. So
otherwise you will get confused.
Yes, and so actually I got confused with certain questions actually. So another point, sir, for the reduced row echelon form, suppose it's a 3 to 4 augmented matrix.
3 cross 4.
3 cross 4. So the first column can be a 0, like suppose x1 can be 0. Like
no.
0.
So what is the definition of row echelon form?
Reduced row echelon form, like
what is the definition of reduced row echelon form?
It should be it's like it should be in definition wise, it should be your pivot, pivot one should be below that.
Come at the beginning, right? All the pivots all the rows which have pivot element should come upper, right? And all the zeros should go lower portion, right?
Yes.
So if suppose first row is starting with 0, so you change it, you interchange the row. Interchanging the row is also row.
No, my point is,
right?
My point is that I'm not talking about row. I'm talking about the first column. Suppose a column starts with 0, 0, 1, 0.
That's my point is, again, you are confusing with column. So if first column is 0, that means the first element of the first row is 0, right?
Yes.
You cannot have it in row echelon form,
Okay.
right? So
Yes.
you have to interchange some rows so that the first element should become 1, or at least there should be no non-zero, then you divide that with that element to get that 1, right?
But suppose one thing, sir, suppose all the cases, the x1 is 0 only. Huh?
In the
x1.
like he is saying let's say column 1 is all 0.
All column 1 is 0, sir.
Okay, column 1 is 0. So apply the whatever the reduced row echelon form, apply on from the second column. Like
Okay. My point is that only. Okay.
Yeah, that is the point. Apply the reduced row with the form, whatever the reduced row or row echelon form, apply from the second column.
Okay.
Like it will be 0, 1, 0 or 0, 1, 1. Next is 0, 0, 1 kind of.
Yes.
Okay,
the first
so
column is 0.
Okay.
That's why I am talking about. I mean, always focus on the rows. Don't focus on the column. Then you will get confused.
No, basically, all the examples that shown in a video generally start with 1, 0, 0, 0, then 0, 1, 0, 0. But in exam also some examples there is something that 0, 1, 0, 0, 0, 0, 0, 1. So
okay, then the first column basically does not, I mean, contribute anything with the solution, right?
Yes.
That variable is free.
Yes.
Right?
Yes.
Yeah. So then what your matrix becomes? Your matrix basically becomes what is starting from the second column.
Okay.
So you have to first find where the first non-zero element is occurring.
Okay.
Make that to the first row. Then do the row operations.
Okay.
Is it clear?
Yes, clear.
Okay, great. Yeah, Shubham, you are saying something.
Yeah, so actually I want to say the office hour is actually a very beautiful session for those who's unable to attend because of some kind of timing, because this is on 8 to 9, which will be very helpful for the working professional. And so I can say I am requesting to who is facing difficulty with the time of the live session, please try to come in office hour and post as much as your queries. Not like today's as one query is the first of practice assignment. We just took for the simplicity, but the best question is for the second question, which is asking for a square is equal to a. He asked not a specific question like an activity or practice. He asked his doubt how to resolve those problems. So such kind of queries, if we introduce in the office hour, then it will be like saying to be the fruitful office hour. That's the mean to conducting the office hour also. So if you are asking activity question or practice question, those are already discussion is going on the discourse, or maybe of those remain 2 sessions also, which is as usual time 9:30 and 4:06 as whatever the days are. So apart from that, if you have some conceptual doubt, how to resolve, how to some particular question, asking some extra kind of knowledge or maybe some concept, it will be not happen extra concept. Always will be some mixing of the concept. It will be. So in such cases, you can post those question in office hour. Then it will be best way to use of the office hour. And this office hour is very useful for who is not able to attend as usual live sessions for 2 hours. So all of you try to use this office hour, and today have already discussed how to post queries and how to see that where is my answer get resolved. I hope all of you got what is office hour and how to use it and what the mean of office hour.
Yeah, that is a great help.
So the a square, sorry, so a square. So the topic that
from my side,
from the first topic.
I'm ending my word. You can. Is there something?
Hello?
Yeah, someone is trying to say something. Who is that?
Yes, I agree, Krishna.
Tell me.
I just have one query from the first example that we taken from the form, that is a square equal to a.
Yeah.
Right? So here we can deduce that since A square is equal to A, the only possibility is A is my identity matrix or
No, why?
so.
That's what Shubham has done, right? So if you
But,
A square equal to A, I mean, obviously 0 is one example and identity matrix is one example, but there can be other matrix also, right? That's what he has derived by the equation, right? Have you seen that?
yeah, I saw it, but I thought it was getting equated to one
So you choose so I am giving you hint. Later you can see it in video, but what you have to do, you choose any arbitrary 2 cross 2 matrix, right? A, B, C, D. Okay. Then calculate what is A square. Okay. Then equate it to A. So equate it to A means all the coordinates should be equal, right? A square equal to A means all the coordinate of A square should be equal to coordinate of A. All the elements of the matrix. Then you will get 4 equations, right? Then you just play around with those equations and you will get some conditions on ABCD, what ABCD should be. So whatever ABCD should satisfy that property, all those will be the possible matrix for the equation A square equal to A. Is it clear?
So randomly,
not only 0 and identity, there will be some more matrices will be there.
Okay. So I'll randomly I've taken 2 by 2. Have
do that.
Do multiplying do a matrix multiplication with itself.
Exactly.
Equal it to A again, and then work out how each element will map.
Exactly.
And then derive the exact values. Okay.
Exactly. Yeah. Right. Yeah. Shreya was asking some question in chat. I have seen. Shreya?
Yes, sir.
Yeah. What is your doubt?
Sir, can you please explain the difference between row echelon form and reduced row echelon form?
So what is row echelon form? Can you tell me?
Sir, in this, the first row contains the first element as 1 and the number below it should be 0.
So basically there is no condition on what the elements above the pivot element, right? Above the pivot element, there can be non-zero elements also, right? But for row echelon, reduced row echelon form, above the pivot element, all the elements should be 0. Okay?
Sir, the voice got disconnected in between. Can you explain again?
Oh, okay. Shubham, can you share the sheet again?
Yeah, okay, sure. So,
and write one reduced row echelon form and row echelon form.
Okay,
2 matrices. Yeah.
So like row echelon form is I'm writing like this. Let's say I'm taking the shape like this. So this is again 0 and this is 0, and let's say this is 1 here and 0 0 0 kind of. So this is actually row echelon form, in row echelon form. But if you want to
1 minute, Shubham, 1 minute. Shreya, can you tell me, is it row echelon form?
Sir, according to me, it is not, because the
Why?
first element of first row is not non-zero.
But all the elements in the column is 0, so there is no need of non-zero element in the first row, right? It start with the non-zero column. Okay. If the column is non-zero, then the first element should be 1.
Like
okay?
here,
Which here it is satisfying. The first column is 0 column, so there is no need of 1 element in the first row. So we start with the second column. Is the first element of the second column is 1? Yes, it is 1. Okay.
Yes, sir.
So that is pivot. So A21 is the pivot element, right? Sorry, A12. A12 is the pivot element, and all the elements below that is 0. Correct?
Yes, sir.
Okay. Then come to the second row. So for the second row, in the third column, the pivot element is again 1. All the element below that is 0. But all the element above the pivot element, there is still non-zero element. So it is row echelon form. Now, if that 2 is also 0, then it is reduced row echelon form.
Now, like here you can change. This is in row echelon form. Reduced row echelon form is also row echelon form. So like if you do is like I am writing like this. Now suppose this is like this. So this is in reduced row echelon form. What in other word, if there is this one is pivot element, so below to be 0. Whatever if I suppose this is here 1, let's say here 1. So if this is the pivot element, above should be 0 and below should be also 0. Like not this is not happening for here. So this is not in reduced row echelon form or also not in row echelon form. So it should be like whatever the pivot element, the all below entries should be 0, and this is the pivot element. So below or above the entries should be 0. So this is the this is the way to get the reduced row echelon form.
Sir, in that case, I am having a doubt over here.
Okay.
If in the activity 2.5 in level 2 there is a 6th question where it is mentioned that let the reduced row echelon form of a matrix A should be something like 1 0 minus 1 0 1 1. How can that be reduced to echelon form then?
So you can do the operations. No. So asking for there are like there are the sets. There is a set given in which contains some 6 matrices or maybe more matrices with the different form. From there you can choose which one is in row echelon form, and there is another the next question is
No, sir, not that one, not that one. In case of activity 2.5, if you go and if you check the question 6, okay.
Okay, let me go to that.
Yeah. Because I was actually solving it and I came across it. I was wondering why it's called as reduced to echelon form. 2.5, question number 6.
Shubham, write that matrix 1 0 minus 1 0 1 1.
Yeah. So how can that
write
be?
that?
It is written that
I
let
am
the
asking
reduce.
you. Okay, Shubham, write that matrix.
0. What is that?
So it is 1 0 minus 1.
1 0 minus 1.
0 1 1.
Yeah.
So who is that? Can you tell me your name?
I'm Kavita.
So Kavita, how many pivots elements are there?
There are actually, if you call it pivot element as 1, then it's 3, but otherwise there are 4. That is non-zero, right?
Pivot element. What is pivot element?
I think 2.
Yeah, right. Which one?
So the first and the second.
First and the second, I mean matrix coordinate wise?
1 1. So 1 1
A11 and A22, right?
Yes, sir.
Shubham, point that out. Point those pivot element.
The
So these two are pivot element. Is it clear?
No, then I have to again, I think, check the lectures because pivot elements are not.
Pivot element means, suppose there is a non-zero column, then in that non-zero column, the first element should be 1.
Oh, it's non-zero. Okay.
So first, consider the first column. It is non-zero column, right?
Right.
Element is 1, so it is pivot. So that first one, A11 is pivot. Now come to the second row.
Okay.
Now second row, second column. That element is also 1. So that is pivot.
Right.
Now there is no third row. Right?
Right. There is no third
row. So there are only 2 pivot elements. And above the pivot element, everything is 0, right?
Right.
Because there is only, for the second column, there is some element which is above the pivot element. And there is no third,
so it's applicable.
Third row.
Okay.
Right.
Okay.
So third column does not play any role for the... Yeah, exactly.
Yeah.
Oh, so I should not even look at the third column then.
Exactly, because there is no third row.
Okay. I was thinking for all the columns it is applicable. Okay, thank you, sir.
So is it clear now?
Sir, I have a doubt.
Yes, sir.
Yeah, I have a doubt related to this. What is the arbitrary column AB? Like while solving this, I didn't get what is the arbitrary column used as the second column to find the matrix A.
I am not getting what your question is.
Arbitrary column.
Yeah.
Arbitrary column is just whatever you have to find out, take that as A and B, any arbitrary number. Okay. Now solve for A and B. Do the row operation and see what are the conditions coming for A and B.
Okay, got it. Okay.
Thank
you.
Hello, sir.
Yeah.
Sir, I have a doubt and solve with class 2.1, question number 7.
Which one?
Sir, Sir,
Shubham,
2.1, question number 7.
Okay.
2.1, question number 7. Okay, I am 2.1, question number 7. So this is basically do some row operation and see row operation, elementary row operation does not change the determinant, right? That you know, right?
Sir, where is elementary operation? I am asking the cofactor of matrix.
Okay, this one,
2.1
this
you said,
question.
no?
Yes,
Question
sir.
number 7. 2.1, question number 7. This one, the cofactor matrix.
Yes, sir.
Oh, I am seeing some other question then.
Okay.
So
Sir,
cofactor.
when I am finding the first minor here, 3. So I'm getting -3 here. First one, sir.
Oh, solve with us, sorry.
So this is maybe calculation mistake. Can you check once again?
No, what is fast cofactor? What is fast cofactor? I mean,
sir,
yeah.
-3.
-1.
What? -3? What is cofactor?
The first cofactor.
What is
Sir, we're
cofactor?
taking the first one, first column, and we're cross multiplying.
What is fast minor?
It's the same thing. Because when we're changing the signs, it becomes cofactor.
So what is 1 minor?
So where
you are deleting first row and first column, right?
First column. Yes, sir.
So what and the determinant of the rest matrix, right? What is that?
I think he's doing the he's multiplying by 3.
I'm multiplying by 3. Yeah.
But
Yeah,
that is not the case, right?
Yes.
Yes.
Got it, no?
I got it, sir.
Okay, good. Yeah. So basically, that is the point. I mean, you can post all your such doubt, conceptual doubt on this office hour session. Okay, then we can discuss like this what we are doing.
Could you explain the independent and dependent variables?
So Shubham, can you open that sheet again? Yeah. So suppose you are taking this reduced row echelon form. This one. Okay, not this one. Put another 0, 0, 0 below.
So we have in the last question just
I am explaining this, then you can ask specific question. Okay.
No, sir, I just want to clarify a small doubt in previous question that the cofactor of A11 is that we have to multiply it with 3 or just it's only -1.
Shubham, go above.
Yeah. Okay. Yeah. Actually,
there is written na what is cofactor.
Yeah, this is the good thing.
Before that.
Okay.
I don't think in this place, no.
System. Yeah, this is determinant. Okay, this here is.
Okay, okay. Yes, we have to multiply.
Before that, so C23, go above, Subham, little bit above. Yeah. So see, observe what is M23. M23 is the minor, so you don't have to multiply, right? You just have to delete that second row and third column, and you will get the matrix. You will get the determinant, right? Cofactor is just multiplying with the sign. Okay, not with the element. Okay. So this is cofactor, But while you are calculating some determinant, then you have to multiply with something. Okay, these two are different. Okay, great.
Okay, sir.
So everything is there in Solve with us. I mean, if you just go through that, you will get what you have to do. Okay.
So one buddy have asked the independent and dependent.
So write 0, 0, 0 below that. So and write x vector x1, x2, x3 after that.
I'm writing here, let's say, or maybe
no side.
Okay.
So equal to some b1, b2, b3. So what are the equation you will get from here? x1 minus x3 equal to b1, right?
Okay, so who had asked this? Let me know in the explained form, like in system form. In the system
yes. So x1.
x1 minus x3.
x3 is equal to b1.
And then
x2 plus x3 is
2
equal to
plus
b3.
x3. Yes, yes.
That b3 should be 0 first of all. Otherwise, there will be no solution, right? Because then 0 will be b3. So b3 should be 0 to have a solution. Otherwise, there will be no solution. Okay. Now, first from the first one, what I can write? x1 equal to b plus x3, right?
Yes, sir.
And x2 equal to b2 plus x3. Now, whenever I am fixing some value for x3, then x1 and x3 both are fixed, right?
Okay, so x1 and x2 are independent. Sorry, dependent.
That
and
we can do,
x3
but I will give you the reason why I am doing it like this. Okay.
Sir, x2 is equal to b2 minus x3.
b2 minus x3. That is okay.
Yeah. So in this
basically,
case, sir, x1 and x2 are dependent and x3 is independent.
Exactly. So how we get that? In the row reduced echelon form, or in the reduced echelon form, or in the row echelon form, whatever that be, consider the pivot element. In which row there are pivot element, those elements are dependent. Someone is talking something else here.
Mute yourself.
Please disturb me.
Avilash Mishra.
Subhajit, I muted you also. Please unmute yourself.
Okay. So whenever there are pivot element in some row, those variables are basically dependent variable. So first pivot element is on the first row, so x1 is dependent. Second pivot element is in second row, so the x2 is dependent. Now there is no pivot element in the third row, right? Because third row is totally 0 here. There is no pivot element. So that vector, that element, that variable x3, that is free.
Sir?
Got it.
Yeah.
Sir, by pivot element, you mean non-zero element?
Pivot element means first row, first column. That element should be 1, right? In row echelon form. That is pivot element, no?
These are pivot.
These are pivot element.
It means that the diagonal should be 1.
Not necessarily, it will be always diagonal. Suppose if you consider the matrix above that. So first pivot element is on. Where is it?
In the third row.
You can write. Here. Suppose you consider this, whatever Shubham just right now just changed. Okay. So it may not be in a diagonal, right? Because second column is 0 column. So we don't have to bother about pivot element in the second row. I mean, in second place, A to 2. Then we go to the third column and make that pivot element. Okay. So in this matrix, can you say which are the dependent and which are the independent? Then it will be clear, I think.
So who had asked can also, or
I think x1 and x3 are dependent, and x2 is independent.
Independent. Yes.
So as here, this one and this one is pivot element.
So if you write the equation, what you will get? x1 minus x3 equal to b1, right? First equation will be same, and the second equation will be x3 equal to b2, right? So there is no condition on x2. x2 can take any value, right? x2 is completely free, and x3 is fixed. x3 is dependent on b2 on the constant, and whenever x3 is fixed, x1 is also fixed, so it is also dependent. Okay, so x1 and x3 are dependent here, and x2 is free. Is it clear?
Yes, sir.
Yeah, great. Okay.
So I hope, that's
Hello, sir.
Yeah.
Sir, we are seeing much question like a double adjugate of a matrix and determinant of adjugate. Sir, can you discuss this?
Not in this live session, okay? So adjugate I have already discussed in my previous live session. So can you go back and see Friday's live session?
Matrix.
I have discussed adjugate. Then you can calculate it from here. Okay. If I am discussing what is the determinant of some adjugate or what is adjugate, then you can calculate the double adjugate from there, right? Because that is repeating the same thing. composition.
After getting the adjoint matrix, adjugate matrix, then again calculate the adjugate of that
matrix.
Sir, I have a question, sir. For an inverse matrix, should we follow that one by determinant and of adjugant matrix, or the your row echelon, reduced row echelon form through that? Which is the right process?
Reduced row echelon form, that will, Gauss elimination process will give you an algorithm to find the, that algorithm is good for programming. Okay. So whenever you are trying to calculate some inverse, it will be better if you follow that process. Okay.
But in mathematically, when you for the exams and everything, so
that depends on how the matrix is. For some matrices, that adjugate formula will give you, quicker result, and for some, Gauss elimination will give you quicker result.
Okay.
So you have to, take your decision at the exam now, what you want to use. Okay. But we will not give you any question which is so much calculative. That is for sure.
Okay.
Sir.
Yeah.
One
Sir, in this
question.
given example,
In the adjugate matrix, we have to find the cofactor matrix, right? So in double adjugate, we have follow the same rules.
So you find the adjugate matrix. Okay. So that is again a matrix. Call that matrix B. Okay. Suppose you start with A. You find adjugate of A. Call that matrix B. Then again find the adjugate of B matrix.
Sir, it is very lengthy calculation, I think.
But where you are requiring this?
Sir, I'm saying in the question and practice assessment too. So.
Then there is some tricks so that you can do it. Quicker.
There may be trick. No need to go with the big long process.
Okay.
And that is for 2x2, right? No?
No, so 3x3. It's mentioned 3x3.
Okay. Which question? Shubham, can you open that?
Yeah.
Sir,
one more thing.
Question number 3.
One minute, I am coming.
Question number 3.
Practice assignment, question number 3.
Yes, sir.
Week 2.
The last part.
Week 2.
Sorry, the
Week 2. Yeah. Question number 3. It went up.
So the last one.
Is 3 question. Okay. Okay, good. Do you know what is determinant of adjugant of A?
Yes, sir.
What is that?
Sir, it is A inverse into by date of A.
No, determinant of adjugant of A.
So determinant of A inverse by determinant of A?
No.
Determinant of A to the power n minus 1.
Exactly, right. So here it is determinant square. Okay. So in the last live session, I have calculated that. How I get that? Just go through my last live session video. You will see that. Okay. So determinant of adjugate of A is basically determinant of A square. Okay. Now try it. You don't have to calculate an adjugate here.
You're dividing by the A inverse. So A inverse means 1 by date.
Right. Exactly. Right. One data will cancel out. Exactly. Yes. Now do it again. Now consider that adjugate of A as B matrix. So basically C is equal to adjugate of B. Right? So determinant of C will be determinant of B square.
So again it will be divided.
Exactly. So you will get that, right? Already you know what is the answer. Okay.
Yes. Okay, sir.
Great. Yeah.
Thank you, sir.
Yeah. Okay. Okay. So Shubham, I think we should stop the session now because it's already.
So just I have just one question regarding the determinant properties. Like if in case that we have the example that if in case we have sum of 2 columns or sum of 2 rows, in that case the determinant would be C. But if we have any case where we have all the we have one column where which is the sum of all the 3 different columns, like different combination of sum. So in that case also determinant. Yes, sir.
So there are basically, suppose Shubham, can you write it once? Suppose write a matrix A equal to C1, C2, C3, where C1, C2, C3 are columns. Okay. C1, C2, C3, right? So there are 3 columns. These are 3 columns. Okay. I am not writing the column totally. Now, what you are asking, suppose there is a matrix A prime which is C1 plus C2 plus C3, C2, C3. Whether these two determinants are same or not, right?
Yeah, it would be same. It would be same. But if it is
why?
the case like we have C1, the first place would be C1 plus C2. Second place would be C2 plus C3. And
that
third
is one
place would
question
be,
in the activity question, I think.
yeah.
What you are
The,
asking, right?
yes. The E4. And another one is like
so
C3
take
is
one
equal
example. Okay, take
C3
one
plus
example.
C1.
Okay, take one example. 1, 1, 1, 0, 1. Okay, right, Shubham, the matrix 1, 1, 0, 1. Now do that operation. Okay, Shubham, you don't do. I want him to do. Okay, so you take that matrix, you do write this new matrix A double prime, whatever you have said, and see what the determinant you get. Okay, then you will get that result. Basically, these two determinant will not be same. Okay, because we cannot do any row operation so that we can go up to A double prime. Okay. Yeah.
So yeah, let's end the session.
Let's end the session. So I hope what is office hour, that is at least clear to everyone, right? So we will expect some questions from you in the next office hour. Okay.
Sure.
Okay, great. Thank you. Good night.
Thank you, sir.
Good night.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir. Good night, sir.
Thank you, sir. Good night.
Thank you, sir. Good night.